We're being asked to find the limit of an equation. Whenever you're being asked to find the limit of an equation, really option one always is the same option. Option one is always going to be to just plug it in. So in this situation, they're wanting to know what happens as t approaches -3. And so option one, basically to check on that, you're just going to plug in -3 everywhere you see a t in that situation. So this is limit as t approaches -3 of t plus 3 over t squared minus 9. So we plug in that -3. We get -3 plus 3, and then on the bottom we get -3 squared minus 9. So on the top we get 0, but more importantly we get 9 minus 9, we get 0 on the bottom. And so anytime we get 0 on the bottom, division by 0 is bad. That is like the biggest no-no in all of math. And so when option 1 fails you, you got to go to option 2. Option 2 here, whenever I see something with a squared, a quadratic, a power of 2 like this, my next bet is I wonder if I can factor and cancel. And when you look at this, you can't factor the top. There's nothing to factor up there. T plus 3 is t plus 3. But on the bottom here, we have t squared minus 9. T squared minus 9 is a very common factoring setup that you got to look out for. They refer to it as the difference of two squares. And so whenever you see a setup like this, the math way of saying it would be like a squared minus b squared. You see it all the time. It's usually something like x squared minus 16, where the front is squared and that back number is something that has a nice clean square root. So maybe if you had x squared minus 16, this factors out to be x plus 4, x minus 4. Something like x squared minus 81, you would factor that to be an x plus 9, x minus 9. This is one of those factoring situations that you just have to be able to identify, and it shows up all the time. We've got that going on right here. And so what we're going to do now is we're going to go ahead and factor that bottom piece using that difference of two squares factoring technique. So the top stays t plus 3. The bottom now becomes t plus 3 times t minus 3. So we just did the factoring part of the factor and cancel. And now what we're going to see out of here is we just cancel out. I've got a t plus 3 on bottom, a t plus 3 on top. And so when I simplify this down, I'm now looking at the limit. When I cancel out on top, that leaves me with a 1. And on the bottom, I have t minus 3. Once you do that canceling part, hopefully you've gotten rid of the trouble spot, and so we're back to option 1, plug it in. So again, we're going to take the -3 and plug it in for t. Only once you go to plug the value in are you able to drop the limit statement. If you look back through my work here, you'll notice that until I got to this last step, I kept the limit statement with me. And you've got to do that or they'll ding you a couple of points on a test or a quiz in class. You have to keep the limit statement till the very end. If I look at this now, I can clean this up. This is now going to be 1 divided by -3 minus 3 gets us -6. And so our final answer for this problem, so the limit as t approaches -3 would be y equals -1/6.